Wind turbine blade testing is an essential process to ensure each blade's durability, efficiency, and environmental resilience before deployment. During these tests, engineers apply intense forces along different axes of the blade, both edgewise and flatwise, to measure resistance to bending, flexing, and twisting. Each blade undergoes static testing, where it is subjected to extreme one-time loads, and fatigue testing, where it experiences continuous, repetitive stress. For example, one side might be exposed to wind force simulations of up to 100 km per hour, pushing the limits to ensure structural resilience and validate design standards. The testing protocols are adjusted based on the blade's size and material, ensuring that it can withstand environmental challenges, from strong storms to erosion caused by wind-borne particles. This rigorous testing is crucial for sustainability, as wind turbines need to operate efficiently with minimal maintenance, optimizing energy production over long periods. Durability in various climates ensures reduced downtime and fewer replacements, supporting environmental goals by lowering material usage and maintenance energy costs. As blades continue to grow larger, these testing processes are continuously updated to ensure the reliability and efficiency of wind energy sources that contribute to global clean energy goals. Transporting enormous wind turbine blades is an intricate and challenging process, primarily due to their sheer size and weight. The DAL system, specially designed for transporting wind blades, is instrumental in simplifying this task, particularly when navigating complex routes with sharp turns or restricted spaces. This system uses advanced self-steering trailer technology with hydraulic lifting adapters, which allow each blade to be lifted, rotated, and angled as needed for maneuverability. This flexibility is essential on winding roads and narrow passages, helping avoid obstacles without needing extensive modifications to the surroundings, such as removing roadside barriers. One of the standout features of the DAL system is its ability to handle the increasing length and weight of wind blades. With newer blades reaching up to 100 meters, the system's adaptable trailer configurations ensure safe and balanced load distribution. Self-supporting technology allows each blade to remain stable throughout the journey, and the dolly-equipped trailers have a wide slewing range, making tight turns more manageable. Additionally, the hydraulic lifting adapter can adjust the height by nearly a meter, which is beneficial when traveling over uneven terrain or beneath low-clearance structures. In practice, the DAL system is used by major transport companies, allowing efficient movement from production sites to installation locations, often in remote areas.